Welcome. In this video, we're going to be looking at domain and range a little more in depth. So we've defined these before, so you should have these definitions already, but we're going to look at what does that look like and how do we actually write it out. So the domain is the input or x values or independent variables or the first coordinates. So this is what we talked about beforehand. So if we are going to write the domain, how we write that is going to depend on whether it is a finite set or an infinite set. So finite set just means it's these values, 1, 2, 3, and 4. An infinite set means it's all of these values between two numbers, which then could include any of the values in between them, not just the values themselves. So a finite set is going to look like a list of things. So if I'm going to write my domain as a finite set, I'm going to use these curly braces and then just list the domain values. So in these two here, this function here has just these particular x values, not any numbers in between them. So this would be a finite set. So my domain is all of the x values here. So I'm just going to list them out. It's 1, 2, 3, 4, 5, and 6. It's those particular values. If any of them repeated, you wouldn't write them multiple times, you just write it once. Okay, whereas if we have an infinite set, so something like this graph over here, we have x values of -1, 0, 1, 2, 3, 4, almost 5. Talk about this here in a second. But we also have all those values in between. So we have 0.2 and 0.457983. All of those values are included because we're looking at all of the values between here. We have a nice continuous graph. So if we are looking at an infinite set, we're looking from left to right because that's our x values, our domain values. And we're going to start with what is the smallest value. So the smallest value is the first value I hit to the left, and that's this -1 here. So we hit this -1, that's our smallest value. All of my x values have to be less than or equal to that. And then we go all the way up until 5. Okay, but if you remember back from our graphing inequalities, an open circle means we don't equal 5, we just get right up to it. So we're going to say that x is less than 5. And we can write it as this compound inequality where we use smallest value or the furthest left, and then x, and then the largest value or the furthest right. Okay, and then you just have to decide, is there an or equal to or not, based on the point at the end there. But it's always going to look like this, always opening to the right, going from smallest to largest. So all of your x values are between the smallest value and this largest value. Okay, let's look at that again, but from the range side. So if we're looking at the range, we're looking at the y values. So for a finite set, it'll look exactly the same, except for we're talking about range. Use your curly braces. We're just listing all of our y values here. So 2, 4, 6, 8, 10, 12. And again, if they repeat, you don't need to write them more than once, just once per time. Okay. Then for our infinite set, looking at our graph here, it's an infinite set. Instead of looking left to right, we're looking bottom to top because we're looking at y values, which are up and down. So we're going to start on the bottom of our graph to find our smallest value. But then we're going to do the exact same thing, that our y, all of our y values are between two things. Our smallest y value is 1. And it can be equal to, because it's a filled in circle. Then we go all the way up to the top and say, what is the largest y value? It is 7. And it can be equal to, because that is also filled in. Okay, so same thing for the y's, that we're going to go smallest, which is the bottom of your graph. And then the largest, which is the top of your graph. And then again, decide if you have the or equal to, depending on if you're a filled in circle or an open circle. Okay, so let's look at some other things that we can look at with these. If we're looking at a function, we can talk about its behavior, whether it is increasing, decreasing, or constant. Anytime we're talking about that, we're talking about the y values. So we're looking at how do the y values change as we go throughout our graph. So we're going to read our graph from left to right, and then we're looking at how do the y values change. So if you have an increasing function, that means that your graph goes up from left to right. Your y values are increasing. If you're a decreasing function, the graph goes down from left to right. The y values are decreasing. And a constant function, the y values do not change as the x values increase. So that looks like a horizontal line. Okay, so if we're looking at this graph over here, we're going to look from left to right. So this part of our graph is increasing. As I go from left to right, we're going up and we reach this peak, and then it goes down. So this is decreasing. And then this last chunk of the graph, my y values are not changing. This is constant. Okay, so we'll be using those terms, increasing, decreasing, constant, to talk about the function. Remember, we're looking at what are the y values doing? Is your graph going up or down as you move from left to right? So what are your y values doing as your x values increase? So let's look at some examples here. Determine whether each is a function, find the domain and range, identify the intervals of increase and decrease. So we have a lot going on here. First thing I want to note is if you're identifying the intervals of increase and decrease, we're looking for what x values are the y values increasing or decreasing. So really we're looking at which x values make your y values do that. So keep that in mind as we're looking. So let's just look through and just decide first, is each relation a function? So we're going to use our vertical line test because we're on a graph, deciding do we have more than one y value per x value? Look okay on this one, right? Any vertical line I draw here only goes once. Okay, let's look at number 2. So say yes, it is a function. Number 2, again, vertical line test looks okay. Yes, it is a function. 3, almost everywhere is okay, but this vertical line has infinitely many. So this is no, not a function. Here, fine, we cross once. Yes, a function. Here we have a nice little line. So again, vertical line test is fine. Yes, it's a function. And this last one, nope, not a function. Okay, so now that we've decided whether it's just a function, let's look at finding our domain and range. So domain, remember we're going to look from left to right. This is a continuous domain because we have all of these points filled in. So I'm going to start on my left and look, where is this first point this is going through? I realize this is not a great graph. This is 10, which means each of these is 2. So it looks like we're at -4 is the smallest. And then we're going to sandwich our little x in there. And then the largest is up here at 12. Then check your endpoints. We're not equal to -4, but we are equal to 12 because we have the filled in circle there. Do the same thing for your range. But now we're starting at the bottom. So the first point we hit at the bottom is -12 y, and it is equal to, if it goes down there, unless it shows an open circle, it is equal to. And then all the way up to, I don't know, call that 22. And this is kind of a tricky one here. When we look at this top point, it's not equal to here, but it is equal to here. In order to be included in the range, it only needs to be equal to once. So since we do hit that point somewhere, we are going to include it in our range. Okay, let's try another one here. Number 2, domain. Oh, this has an arrow. Means this keep going forever, so it doesn't ever reach anywhere there, and it doesn't ever reach anywhere there. It covers all of the values. So we could write this in our inequality notation and say negative infinity to infinity, or we could say we just hit all of the real numbers and use this double bar R symbol, which means all real numbers. So either is completely acceptable. Okay, let's take a look at another one here. Okay, I'm looking left to right. The only value we hit is 3, so that is a finite set. So my domain is just 3. We are going to use our curly braces there to say it's just the number 3. Realize I didn't do range on number 2. We'll go back to that in just a second. Okay, range here, we're going up and down forever. So just like the left and right forever on number 2, we could say it's from negative infinity to infinity, sandwiching our y's, or you could use that double bar R, the all real numbers for your range. Let's go back up to number 2 here and look at our range. Okay, they go down forever, so we don't ever hit anything in the bottom. So we could say negative infinity less than y less than or equal to negative 2, right? That's the top one we get to. Or you could just say y is less than or equal to negative 2, and that would cover all of those values. We're going down forever. You don't have to include this part here. It's not wrong if you do. Okay, moving on to number 4, domain. We go left and right forever. All real numbers. Range only hits the value negative 1. Right, the only y value we hit here the whole time is negative 1. Okay, number 5. We're continuing left forever, continuing right forever. So our domain is all real numbers. Our range, we're continuing down forever, continuing up forever. Also all real numbers. And last one here, number 6. Domain, continue left forever, all the way up to 0. We're looking left to right. So we could write negative infinity is less than x is less than or equal to 0. Or we could just say x is less than or equal to 0. Either is totally fine. Okay, range, this is continuing down forever. This is continuing up forever. So our range is all real numbers. Okay, domain and range. Now let's see, what's our last thing? Identify the intervals of increase and decrease. Okay, so we're looking from left to right. So from left to right, this is going down until we get here, which that looks like about 4. Looking for the x value. So from negative 4 x value to x value of 4, we are decreasing from negative 4 to 4. Right, again, we're looking at the x values. What is the y value doing? So we're going down on this chunk of the graph, and then we're saying what x values does that cover from negative 4 to 4? And then it's going up from here to here. So increasing from 4 to 12. Okay, this is a little harder, trickier to think about because we're including those x values and y values. So here we're going up. Oh, this keeps going for forever. So up to 6. So we're increasing. You could say from negative infinity to 6, or you could just say increasing when x is less than 6, and then decreasing on the other side of that after 6 when x is greater than 6. This is an interesting one. Okay, this is just going straight up and down, which means we don't have x values changing at all. This also is not a function. So if it's not a function, we're not going to talk about intervals of increasing and decreasing in general, because it can be doing multiple things at the same x value, y value. You could look at this as going up or down. Either way, we're not going to talk about intervals of increasing or decreasing. when it is not a function. So we can skip 6 and 5 on that. Number 4 here. Oh, my y value is the same. So this is constant for all values of x. It is the same all the way across. And last one, we're going to look at increasing and decreasing as I go left to right. This is increasing for all values of x. Okay, and again, number 6 is not a function, so we can't talk about increasing and decreasing because it is doing both at the same time, so that does not make sense. So all of those little things are details about our graph that are going to help us understand graphs better. Make sure that you're focusing in on what does domain and range look like and those new vocabulary with increasing and decreasing. Thank you so much for watching.